Hey, welcome back to the CCNA series. In this video, we're going to discuss about spanning tree protocol, a fresh look. So if you remember, the idea is to go into some of these CCNA topics and have an approach, a different approach from what we are used to or from what we can find in documentation or some other videos. I'm Agustin Ciciliani. I'm with Firefly, and our vision is changing the way we learn, evaluate, and adopt technology. Okay, so here are the topics we're going to discuss about spanning tree. So first of all, I'm going to introduce you to Radia Perelman. Who was she? What was her role in the development of spanning tree? Some history and background. Then, yes, again, we're going to see a couple of details of graph theory. If you had a chance to check the OSPF Singularity video, we also have some details about graph theory and how this all relates to our protocols. So go and check that out. Then we're going to discuss the evolution and the different STP flavors that we have for configuration. And last but not least, we're going to do a lab demo with 3 different approaches of how to configure a spanning tree protocol and pros and cons and the best way to do it. Okay, let's start with some spanning tree protocol history and background. Let me introduce you first to Radia Perelman. She was key in the development of the spanning tree protocol. She's also known as the mother of the internet. And basically, she developed the basis of the protocol when she was working for Digital Equipment Corporation. And she had the assignment to create an algorithm for bridges or for switches connecting different LAN segments or different collision domains, right? This is in the old Ethernet world. So here we have like a drawing from her white paper. You can get it from the internet. It's in a PDF. Where you have, the names that she put to the different states of the algorithm of the protocol. And a fun fact is that she created this algorithm, which kind of summarizes how the protocol works in a very nice fashion. So it says, I think that I shall never see a graph more lovely than a tree. A tree whose crucial property is a loop-free connectivity. A tree which must be sure to span so packets can reach every LAN. First, the root must be selected by ID. It is elected. Least cost paths from root are traced in the tree. These paths are placed. A mesh is made by folks like me. Then bridges find a spanning tree. Very nice. Okay, some more details about spanning tree protocol history and background. So after Radia Perelman finished her work on her white paper, the IEEE took that as the baseline for the actual standard that we know today as the 802.1d, which was the first version of the spanning tree protocol. The IEEE is the Institute of Electrical and Electronics Engineers, and they are basically organized in different groups. Let me show you real quick here part of their webpage. If you see particularly the 802 committee is the LAN-MAN Standards Committee, and they have different working groups or study groups. I'm sure you have heard about the 802.11, which is for the wireless. And in our particular case, this is 802.1, right, where we have all the LAN and MAN standards, right? And in our case, for the spanning tree protocol as well. I would say that the 802 committee is like the layer 1 team, I guess, and the 802.1 is the layer 2 team. We can think of them like that. And basically, the most important standards in terms of spanning tree protocol were, as I was saying in the beginning, the 802.1d, which was basically to interconnect MAC bridges, and it had the baselines of the protocol. Then a couple of enhancements, basically the 802.1w, which is for rapid spanning tree, and finally the 802.1s, which is for multiple spanning tree, the well known as MST.